Alright, good day everyone. I'm Jinky Dahili and I'm about to discuss about the intermediate Java programming. So, what is intermediate Java? The intermediate Java programming course builds on the introduction to Java programming course and builds a strong foundation of object-oriented programming concepts used towards solving real-world problems. So now, what is intermediate level in programming? Well, intermediate level programming builds upon the learner's foundational knowledge in the content area. Programming at the intermediate level includes more deep than that which is associated with the beginning level program. Intermediate level programming may also focus on the integration of skills. Intermediate Java has Java arrays. Arrays are powerful for organizing variables. They allow you to string related variables together into one single variable that's easy to use. It also has method Java revisited. It's time to take another look at method in Java. Without a complete understanding of how method work, it will be difficult to make the leap into object-oriented programming. And also the logical operators. Without logical operators, your code will become confusing and incapable of performing complex logical tasks. Also, into to Java objects. In order to begin programming the object-oriented way in Java, you've got to know what objects are, how to create them, and how to use them. We'll also learn about the creating Java objects. In part 2 of working with Java objects, we'll create a Java object from scratch. We will then use the object to further show why the object was created the way that it was. Learn what you need to know about getter, setters, and object variable as well. And also, we are going to learn about the Java constructors. Part 3 of using Java Object Explorers, how Java constructors work and what they are used for. The power of constructors lies in initializing data upfront. And the lastly is the Java package. Here, we'll cover the Java's way of making sure large programs stay organized. Packages learn how package help to enforce good coding standard and help you, the programmer, stay on top of your program organization. Java array syntax. A Java array is created using the following format. In the first part of the code, you saw int, open and close bracket. This is how you create an array of integers. It looks almost like creating a regular integer variable, but notice how there are square brackets next to it. That means that we want to create an integer array and not a single variable. Numbers is what we're calling this integer array. That part is the same as a regular variable. The part after the equal sign is sort of new, but it's actually something you've seen before. Do you remember this? We are creating a new array, the same way a new scanner is created. Arrays are not created from classes, but they are little more advanced than the basic types. You'll note that there are a number inside the other set of square bracket. This number is size of the array. In other words, it's the number of integer variables you want to have. I choose 5 for the example, meaning I want to create 5 integer variables. Using Java arrays. Arrays is just a bunch of storage space. Each of these space given a number, starting from 0. To access one of these storage squares, you simply give the number of the space you want after the variable name. Let's look at our previous example and access the first element, the storage space marked as a 0. That stores the number 5 in our integer array called number, and it stores it in space in which is first spot in the arrays. See our example. Notice how I stop at 4 and not at 5. What would happen if I did this? I will get an array out of bounds exceptions. Basically, Java will telling me that I have gone too far and that there's no space 5. Remember, we had said that this arrays only has 5 spots, and those 5 spots are 0, 1, 2, 3, and 4. There is no 5. And Java will complain and your program will not work correctly. You won't actually get an error. This will happen once your program has already started, so you have to be extra careful. Methods in Java Revisited. We're going to talk about method scope. Methods in Java are used to make code easier to read and to make sure that code is not duplicated. Code that needs to be run over and over again is placed in method, which is just a sequence of instructions, all placed together in one spot. This is basically what methods are, but it's important to make sure we've got the details nailed down. In other words, you need to know how method in Java truly work so that you know how to best use them. Method in Java have their own scope. What is method scope? Scope is what you can see in this case. It's what Java can see. Let's use iScope as an example. Anything you see will be within your iScope. Anything beyond that is out of your sight, and that's out of your scope. If you live in the United States, you can't walk out of your house and see China in the distance. China is said to be out of your eyes scope. There's simply no way you're going to see it. Anything inside the method in Java is inside of the method scope. When Java is executing code inside of a methods, its scope is limited to whatever is inside that method. It cannot look beyond the method. So, what exactly do I mean? Variables can be created anywhere in your program. You typically create variables inside the method, such as the main method or some other Java method that you create. Here's an example of a program with two methods, and it has variables being created inside of each method. We're going to see which variables a program can see depending on which part of the code your program is executing. There are variables created in the main method, and there is a variable created in other method. Another Java method. When the program is inside the main method, it can print out the value of num and pi because they are still within the scope of the method. Trying printing out the value of num inside the other method. Notice how in my example, my compiler in Eclipse is showing me that I have an error when I try to print out the value of num when I'm inside another method. This is because there is no way to see the variable num from within another method beside the main. So it is said to be out of scope. The same is true if I try to print out the value of num2 inside the main method. Now, see the script at the left side. This didn't work the exact same reason. Inside the main method, Java can see any variables created in other methods. Get rid of, fix the line of the code that have errors in them and run the program. So as you can see, it just show on the Eclipse only 5 and 3.14. You'll see that only 2 of the print line actually work. What happened to the third one? Remember, Java programs start at the top of the main method. This means that Java starts executing code beginning within the first line. It finds inside the main method. Java creates the num variable, the pi variable, print out the num variable, print out the pi variable, and then reaches the end of the main. When that happens, the program finished. It never gets to the other method, so it never print out the value of num2. It never even created the num2 variable. Calling methods. So how are we going to get Java to go to our another method? Simple. We have to call the method. Calling method in Java is much easier shown than explained. So here's how I call other method. Now, if you run the program, you will see all three output. What happens is when Java reaches the other method line of code, that's a signal for it to go into into that method. So then the program jumps to first line inside of the other method, which happen to be when you create variable num2. When Java reaches the end of that method, it goes back to main, where it came from and continues to execute code. I'll add another code print statement inside of the main to illustrate. If you run the program now, you'll see that it prints out hello world. Last, this is because Java goes inside another method or other method. Then when it reaches the end of that method, goes back to where it last was inside of main and continue with the next line of code. I recommend creating your own method and experimenting with how Java hops around from one method to another. It's possible to go into another method from main and then inside that other method hop into yet another method. Code out that example yourself and check out your result. Trace how Java execute the code with your finger to prove to yourself that you can follow along with the code and that you know why Java output everything in the order that it did. Next is passing parameters. Creating method in Java seems useless if we stick to the example I've shown and you're hopefully followed. What if another method needs to use the same variables that were created in the main method? This can be done by passing those variables as parameters. What this does is it makes a copy of a variables you want to send to other method for it to use. They are copied temporarily until the method finishes. Then, those temporary variables go away. Note, all methods in Java work this way, unlike in other language. For example, C++ has a way to pass a reference to actual variable. Java has no such thing. To pass variables, all you have to do is to put the variables inside of the method. call parentheses. Here's an example of how I would pass num and pi to other method. You'll see that I put num and pi inside the parentheses when I call the other methods. However, this is only half of the story. If you're following along with your code, you'll notice that you get an error. This is because the method needs to allow those two parameters to be passed to it. It's not enough to say, okay, this method will accept two variables. You need to tell the method exactly what variables are going to be given to it. Here is how I would set up other method to accept the variables num and pi. Note how I put the list of accepted variables inside of the parentheses. The method accepts two variables, an integer variables and a double variable. I also had to name the variables. Yes, the names of these variables are the same as the one in the main method, but they do not have to be. That's right. I could have called those two variables variable 1 and variable 2, and it wouldn't make a difference. This is because these parameters are really just copies of the original variables. Remember, other method cannot see the variable created in the main method because they are out of scope. The order in which you pass the parameter is important too. I put the integer variable first, then the double, so that how you have to pass the values. In the main, you cannot put pi first and then num because other method take first an integer and then a double. All methods in Java like C++ and other object-oriented language enforce the ordering of pass parameter. Once you pass your variables, you're free to use of them. Logical operators. Every programming language has its own logical operator, or at least a way of expressing logic. Java's logical operators are split into two subtypes, relational and the conditional. You can use these operators to make your program much more flexible and powerful. You'll also see the added benefits of making your code even that much easier to read and to write. Next is the relational operators. You should have seen the operators before if you've been following this tutorial. I'm going to complete the list so you will have all the Java's relational operators in front of you. At the left corner of this slide, you can see an image of the conditional symbols and their meanings. Relational operators are used primarily in if statement, while loops and on occasion for loops. There should not be any other cases of their usage. The only addition I made from the previous list is the is not equal to symbol. Here is how it looks like in an if statement. Now, the if statement is true when the variable num is not equal to 3. Otherwise, the condition is true. Conditional operators. There are four logical operators in Java. However, one of them is less commonly used, and I will not discuss here. It's really optional compared to the ones I will introduce, and this will be a whole heck of a lot useful to you. Now, here's your table of logical operators at the left side. Conditional operators, like their relational counterpart, are also mostly used in if statement, while loops and for loops. The best way to show how effective these are is to just show you how they make your code look a lot cleaner. And operator. Let's say you wanted your program to output you win when num1 is equal to 3 and num2 is equal to 5. First, Java will look at the first if statement. Then, if it's true, it will go on to the second statement, if statement. If that one is also true, then it will print out you win. On the screen, seems simple enough, but there has to be a better way than putting an if statement inside of another if statement. There is enter and end operator. Do you see how much cleaner that code looks? It even sounds better when you say it in English. If num1 is equal to 3 and num2 is equal to 5, then output, you win. This is much better. The next one is the OR operator. Up until this point, it was ridiculously difficult to make a bunch of if statement so that the program will execute a piece of code if only one out of several conditions is true. The OR operator allows just this, the ability to have an if statement to be true if only one of the several conditions meet. Do you see how this example of code is different from the previous? The code will run if num1 is equal to 3 or num2 is equal to 5. Only one of them has to be true or for that to happen. If are true, that's fine also. The only time that if statement will be false is when num1 is not equal to 3 and num2 is not equal to 5. Learning about the logical operators means that you too will need to brush up on your logic. I think the easiest way to put it is like this. N is when you need everything to be true, while OR is when you need only one thing to be true. That's really all there is to it. There is a common mistake I always see when people use the OR operator. To give more emphasis on OR operator, the editor I use, Eclipse, will show this line as an error. Do you understand why? Those just starting out believe that through clever use of parentheses, they can make that means that num1 can be equal to 3 or 5. This, however, is wrong. Do not try to shorten your logic statements in this way because Java doesn't understand what it means. Even though it looks like it should work, it doesn't. Remember, Java always executes code inside parentheses first. In this case, it looks like inside the parentheses sees 3 or 4 and has no idea what that means. Do not fall for this trap and make sure you always use the OR operator in a proper way. The next one is the NOT operator. The NOT operator is probably the easiest to understand. It is simply the opposite of what the condition says. Notice how I need to an extra set of parentheses. Basically, the if statement says if not num1 is equal to 3. In other words, if num1 is not equal to 3, do you see how that works? I will definitely try it out on your own so you can see the result. If you notice the statement is not equal to looks awfully familiar. Wait a second. This is the exact same thing. You'll notice this is an easier way to use is not equal to. In general, you should be using this other form and not the previous one. as this is easier to read. Here's a much better example of using the not operator on its own. Order of logical operators. Logical operators also have an order of operations. This is incredibly important when you start to mix and match operators. And operators always happens before OR operators. In Java, only parentheses can give them a different order. Let's look at the following example at the left side. What do you think will happen? Will Java display you with? Let's read the logic. If num1 is equal to 9 and num2 is equal to 2 or num3 is equal to 7, so supposedly you might say, okay, since num1 is not equal to 9, then the rest of the statement does not matter and nothing will be displayed. Wrong. Java reads this statement strictly from left to right. Here is what really happens. Java looks at the first two conditions. If num1 is equal to 9 or if num2 is equal to 2, then it determines that neither of those are true. Then it looks at the OR operator. Java then says, okay, is the other side of the OR operators true? Since num3 is indeed equal to 7, you win will be displayed. It looks the first two conditions, combined them, and then compare that to the other side of the OR operator. To get the previous result, you will need to wrap the OR part in the parentheses like this. Now, nothing will be displayed until you get comfortable with all these logic operators and logic behind them. You should try using as many parentheses as possible. This will make sure you do not get confused as to how the logic is grouped. I hope that this rundown of the different logical operators makes sense and that you can start applying them to your programs right away. They are incredibly useful and will allow you to make much more sophisticated program. Try coming up with different experiments using most of the logical operators or that you get a better feel for handling them. Java objects. Without understanding Java objects, you will never be able to master the language. Java is an object-oriented programming language, and objects are the result of the style of programming. C++, another object-oriented language, has its own object, and they work similarly to those of Java. However, today, you're gonna find out what these objects are and hopefully figure out how Java truly works. What is an object? When you look at the world around you, what do you see? You see objects. In programming, objects are nothing more than representation of things. It's actually pretty simple. The world around you is a representation of stuff. You look at something and you can probably tell me its characteristics. It's an object. It may be more specific than that. It might be a car object or a keyboard object or a person object, but it is still an object. Java has a slightly different definition, but it is almost identical to a real-life object. Classes are blueprints of objects. All Java classes are the blueprint of objects. Period. Every program you've ever written with the main method inside of the class can be an object. Not all classes are used as objects, but they can be objects regardless. For example, scanner is a Java object. It is also a class. But from now on, we're going to call it an object. The scanner object's characteristics are that it accepts user input in various different ways. Using another Java class. Let's try using one of your own classes as an object in other class. I'm going to show example of two different classes. There are my two classes. Now, I'm going to use my method class as an object inside of Hello World. In order to do this, you have to make sure that both Java files are in the same folder. In Eclipse, you also have to make sure they are in the same package. If you've been creating all of your programs in the default package, then this will be a problem. For those using other editors, just make sure both of your Java classes are in the same folder or on your computer. I created a new method object inside of my Hello World class. It was created the same way that I would create a scanner, except that I did not have to put system inside of the parentheses. I call this new object my object, but I could have called it by another variable name. Now that I have my new object inside of Hello World, I'm going to use it to access one of its methods. Notice how the method class has a method called methods too. Now run the program. You should see that it's displayed 3.14159 under Hello World. This is because that it was that method is supposed to do. You can look back at the methods class to verify this. Remember that with a scanner, you did not you did the same thing. You called the scanner a name and then use it in the same way to access it readline or readInt methods. Creating a new object. So far, I've demonstrated object using previous programs. However, not all objects are going to need that main method we're so used to using. I have said that Java objects are a lot like objects in real life. So let's create a real life object from scratch. Let's create a dog. To begin creating Java object, we'll create a new Java class named dog. Leave it as such. Next, we need to think about what a dog is. A dog is just a set of characteristics that makes it different from another objects. Let's make a list of what make a dog. Dog characteristics are four legs, tail, furry. This is a very small list, but one we can work with for now. This will be the three traits that will we give to our example dog object when creating Java objects. Lists like this can help keep track of what you need to code. We need to create a variable to store these traits. This variable need to be defined for the enter object. So, we are not going to create them inside of any methods. Create these variables as shown at the left side. First of all, these variables were created by putting the word private in front of them. This means that this variable can only be used inside of the dog object. Simple as that. Then I create four variables. One to store the number of legs, one to tell me if the dog has a tail, another to tell me what type of hair the dog has, and the last variable tells me the sounds of this dog makes. The default constructor. All objects has a default constructor. This is true of even the other programs that we've made throughout this tutorial. Here is the constructor for the dog for our object dog. You'll notice that it looks almost like a method. The difference is the default constructor is public without the keyword static and has no return type, meaning it does not have void or int or anything else. Also, the name of the constructor is the same as the name of the object. All constructors must be the name of the object. There are no exemptions to this rule. What makes this the default constructor is that it has no parameters inside of the parentheses. The parentheses have nothing in them. So why have you never seen this in any of our programs before? Didn't I just say that all classes have the default constructors? The default constructor is created automatically when creating Java object. You do not need to write it if you're not going to use it for anything. In general, through in general, though it is a good habit to create a default constructor for Java classes that will be used as object, and I will be doing that in my example from now on. Now we're going to discuss about the getters and setters. When creating Java objects, it's a good idea to give other objects access to some information about your object in order to let other objects and classes have access to dog variables. We need to create getters in order for outside object and classes to change the variables. We need to create setters. Here's what I mean in a real-world analogy. Let's say there's a painting. The painting will have characteristics like how tall it is, what color are used, etc. Who cares about these properties? Though, unless you can see them. In order to allow the outside world to see these properties, there need to be a way to get these properties to others. That's exactly what getters do. The They provide the eye that others use to see the object's variables. Now, say you created a painting, but you want to change it a little bit. You need to be able to change the properties of the painting. In other words, you want to change its variable. Setters give you access to variable in case you want to modify the data inside. A painter might do this with a brush. Think of the painter's brush as the setter for changing a property of the painting. In this case, the color. Let's create getter and setter for a leg variable. Okay, so you see the method getLeg. That's the getter. Notice how I name it getLeg. It does not have to be named this way, but it is an industry standard to name your getter method with a get in front of it, and then the variable name. Its return type is its integer, because leg is an integer and that's all. Notice how it is not static. Getter and setter should not be static. Although to keep this tutorial short, I will not go into why that is. The setter method is setLeg. integer x. Notice how I have one integer parameter called x. Remember, to set the variable, you need to give it the new data. So, that is what's being done. The return type is void because you are not returning anything. You are just setting data. Again, this method is not static. See how I pass in a variable called x as a parameter. I could also easily pass in the variable called leg. But, wait a minute. How can that passively work? It can't, just Java can't tell the difference between the leg parameter and the leg variables in dog. However, I claim that this can still be done. The keyword is used here is this. There, now Java knows that this leg refers to the variable declared at the top and not the parent parameter. Continue to create getter and setter for each variable until your program looks like this. Using your dog object. Creating Java object is not hard. Now let's learn how to use them. With the basic properties of a dog defined, we may now create dogs. To do this, we need to create another class, create a new Java file called dog creator, and give it a main method. We'll be needing the main method so we can run the program. Create a dog object the way you would any other object. Now, we need to give our new dog some properties. Remember, we need to say how many legs it has, whether it has a tail or not, and what kind of hair has the dog. Do this, all you have to do, to do this, all you have to do is call those setter method, giving them the appropriate information you want. In my example at the left side, I said that the dog should have 4 legs, that its tail property should be true, meaning it has a tail, and that its hair is furry. Now that you have set the variables, we can easily get the data back and make use of the information. I'll just write some code that display at the information of this dog. This will print out all the information on our dog object. Notice how I made the method call inside the print line. This is allowed because the method returns data that can be easily printed out. The primitive types, the basic type, as well as the string are easily printed out. So it is okay to put this method calls inside of the print line statement. If this method did not return anything, or if they return something that's not easily print out, you will either get garbage as output or an error in Java telling you to fix the problem. One benefit of creating Java object is that you can create more than one object. You can create more dog objects, each one being its own separate entity. Just make sure to name each new dog variable something different. For example, I could create a dog 2, dog 3, and dog 4 and give them completely different properties. Understanding the Java constructor. All Java objects have to be created at some point. These objects use a Java constructor to create themselves because constructor tell Java how to create the object. C++ and other object-oriented language also have the concept of constructor. So for those who know what they are, this will be an overview in order to make the most of your object. However, you'll need to know how to create this constructor. The default Java constructor has been discussed before. All Java objects have a constructor even if you don't specifically code it. The same as not writing a constructor at all would be this. Inside the class is the default constructor. Again, constructor must be the name of the class, and the constructor must not have a return type at all. What constructors do? Constructors may contain code that is run when the object is created. It is sort of like setup code that you want done so the object is ready for what it's supposed to do. Here's an example of what I'm talking about at the left side. You no longer have to create an object and then fill the initial data with setter. You can skip the setters initially by using the constructor to set your data up. This doesn't mean setters are useless because your data can change. However, this is just a way of making sure you don't create objects such as dog initially with no leg. That's just an example, of course. What constructors do? Constructors is Java may be overloaded. This means that the class can have more than one constructor. This is useful for when you want the object to be created with different parameters upfront. There are two ways a Java constructor can be overwritten. Give the new constructor a different number of parameters, or give the new constructor at least one different type of parameter. Here's an example of overloading the default constructor. Java can still tell the difference between all those different constructors because the data that has to be given to them are all different, either by amount or by type. You also notice that all of the constructors set their data in slightly different way. In general, though I prepare to call the setters from inside the constructor, like in the third constructor in the example above. This way, you're not writing duplicate code. If you couldn't tell that this was part 3 of the Java object tutorial, you now have all information you need to create sophisticated objects. Remember, objects do not have to represent real-life objects that you can touch. Ideas can be objects too. You can create objects that contains a bunch of math formulas, or objects that only stores data and don't do anything else. It is up to you to decide what objects your program need, and it's up to you to decide how to use them. Objects are the biggest component of object-oriented programming. It's called object-oriented for a reason, and I highly recommend mastering the whole process of creating a Java object. It's critical to know for just about every object-oriented language I can think of. The last topic is the Java package. Once programs start to get larger and larger, Java package becomes more and more important to use for organization. They help to group like component of the program together and make sure that the certain Java classes only interact with the certain other classes. Otherwise, you may end up with a big confusing mess. Now, you can use your new package to put files in a simple. So, what is the benefit of package? As I've mentioned, Java package help to separate your program so that it's more organized and make more sense, especially when your programs start getting large. Let's say we have a program that simulates the whole world. Yes, that would be a huge program. We may want to break up this world program in more manageable bite-sized pieces. For example, I'm going to create a new project called World and create three packages. One called Nature, one called Society, and one called Util. Why I'm creating these packages? Basically, it involves thinking about what the program might do beforehand. Earth has nature, Earth has society, which is human being, and util. What is util? I'll get to that. Basically, any kind of objects I want to create, such as grass, trees, animals, or atmosphere, would go on into the nature package. It makes good sense to do this because, well, these are all processes that belongs to nature. It's also quite possible that different parts of the nature will interact with each other. Next is the Java classes inside package. I'm going to create a human object inside of the society package to show you how package affect the code. Notice how at the very top, Java declares what package the class is in. This is done for you by Eclipse. With other Java editor, that line would have to be added manually because your classes will now all be in a separate package. No longer will the classes be able to automatically detect all the other classes in your program. If I create a class inside of my nature package and I want to use the human class I created in the society package, then I will need to import the human class. Importing is done the same way as all other import done throughout this tutorial so far. However, here's an example for those not using an amazing tools like Eclipse. You'll notice that instead of something like Java util scanner, I got a society.human. The package name must always go in front of this class. Class name when you go to import it. That's how Java knows where to look. There is another huge benefit to separating your class into packages that I will not go into here. It involves explaining what private and public are, and I will leave the discussion for then. So until then, you may organize your program more appropriately using the awesome structuring of Java package.